Okay, so now we're going to look at solving quadratic inequalities. Okay, so you need to recognize this as a quadratic inequality because this is a quadratic expression here, yeah? And in order to solve it, okay, we just need to think about what this is for a minute. Now, this obviously represents an equation of a curve, yeah? And we know what the shape of that curve looks like, okay? So it's like a smiley face, all right? So it could look, for instance, like this. Like that, it could look like that. Now, we're interested in the values of x, because that's what we're saying here. Find a range of values of x such that this equation here, so this curve is greater than or equal to 0. So in other words, it's got to be positive, okay, or it can equal 0. Now, think about the curve here, okay, where it would be positive. And it's all in relation to the y-axis, yeah? Because if you think about it, it's positive when you're up here, above the x-axis, okay? So it's positive here, but it's negative when the curve is underneath the x-axis, yeah? So we're going to be interested in those x values there, okay? So that the curve is positive. So we'll look at that in a minute. But in order to establish what those x values are, what I'm going to do is I'm going to home in on these particular points here. Now these points we call the sort of critical points, because at those points, okay, it kind of decides then, you can either go one way, can't you? At that particular point, you can either go in the positive y values or the negative y values, okay? And the same there, you can either go positive y or negative y. So it's kind of like the border, yeah, like the border of two countries. So I'm going to be focusing on them, and what we do, we call them the critical points. So I'm going to try and find them, okay? So what I say is, for the critical points, okay, now how do we find them? We need to appreciate, of course, at those points, the curve is equal to 0, isn't it? Okay, so we're going to find those points by setting this curve equal to 0. Okay, so that's how I find them, where the curve is equal to 0 here, where the y value is 0. So all I've got to do then is solve this. And of course we recognize this as a quadratic, okay, and with a quadratic we'll have two brackets equal to 0, solving then, and you put x in both brackets if you remember. And what we need then is two numbers that multiply to give this number at the end 10 and add up to give 7. Now if you think of the pairs that multiply to give 10, you've got 1 and 10, 2 and 5, okay? Now this pair obviously will work because I can get them to add up to give 7. And in fact, if we make them both plus, okay, it works, okay? You can check, multiply out, you get back to that. So when we've got two brackets times together and equal 0, that means then one of those brackets has got to be 0, yeah? Because when you times two things together and the answer is 0, one of those things must be 0. So the first bracket is 0 or the second bracket is 0. So in this case, if x plus 2 is 0, take the 2 over, that means x is equal to minus 2. And if x plus 5 is 0, take the 5 over, x is equal to minus 5. Okay, so it's very close actually to what we've got there, isn't it? Let me just draw it a little bit bigger. So we've got minus 2, and this is just going to be a sketch, right? Minus 5 here. Just draw a curve now. Let's turn it upside down. It's a lot easier to draw it. If we turn it upside down, turn this around a bit. And let's think back then to our inequality. So remember now, we want to solve this. So we're interested in when the curve is positive or 0, okay, but essentially above the x-axis. So if you think about it, it's this section of the curve here, yeah? That's going to be positive there. So it's going to be all of these x values that's beyond minus 2, so greater than minus 2, all of those x values there. Or it could be this section of the curve here. Okay, that gives us a positive value. So it's going to be all those values from minus 5 downwards, okay, to negative infinity. So what we say is x, okay, in terms of our answer, could equal to minus 5 or less. Okay, and it would produce positive values to that curve. So we could say x has got to be less than minus 5. Okay, or x could be greater than or equal to minus 2. Okay, so if x is in either one of these ranges, then it satisfies this inequality. In other words, the inequality is positive or 0, okay, when x is minus 2 or more, because we've got positive values of the curve there, or minus 5 or less, because we've got positive values there. So it could be either or, right? So it's important you put that word or in there, and we've solved our inequality.